Mechanics Chapter 6, problem number 6.59. So in this problem, we have this figure. We have the support joints A and N, which is a ruler and a pin. So we know the forces along that supports, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 joints having a forces at A, which is 200 pounds, at B 400 pounds, at D 400 pounds, at F 400 pounds, at H 350 pounds, at I 300 pounds, at K 300 pounds, 300 pounds at M, and 150 pounds at joint N. So basically what we have to do is to first draw a free body diagram of this problem. So I already did it. So this is the free body diagram of this problem. Wait, free body there. Okay, so in this problem we're tasked to find the forces along DF, forces along EF, and forces along EG. So because 6 feet is common in this problem, which is the distance along AB, BD, DF, and all. So I changed the force 6 feet into a constant, which is alpha. So I use alpha to substitute 6 feet. So what first we need to find the summation of forces along X. So we know that the only force along X is this one, NX, because the support in this joint is a pin joint, so a pin support. So in pin support we know that the forces acting on it are two, which are the N, the Y and X component of that support. So this is what will happen. So the force along X is equal to 0, which is equal also to NX. So NX is equal to 0. Then using the moment at N, so 200 pounds plus 200 pounds times 8 alpha, 8 alpha meaning this 8 times 6, because alpha we know it's 6, right? So plus 400 pounds times 6 times 7 alpha plus 6 alpha plus 5 alpha. Why is this? I will explain this later. So plus 350 pounds times 4 alpha plus 300 pounds times 3 alpha plus 2 alpha plus alpha minus A, which is opposing force, times 8 alpha. Okay, gets. So what happens here is simply just like this. So 200 times 8 times 6 alpha, we know alpha is equal to 6 here. So 400 times 7 times 6 plus so on and so forth. So having it this way, we will get a solution of 1,500 pounds or 1,500 pounds. Sorry, I forgot the unit. It's pounds going upward because it's not a opposing force. Because it's a opposing force. Sorry. So next we will find the forces along Y. So there are so many forces along Y. We just have to find which are opposing or not opposing force. Okay. So summation of forces along Y is equal to 0, as we know. So 1,000 pounds, which is this A, so it's an opposing force, so it's positive, minus 200 pounds, minus 400 pounds, which these 400 pounds are basically just this one. So 400, 400. So you have 400 pounds. So that's, I just simplify it. Minus 350 pounds minus 300 times 3 pounds, which is 300 pounds, 300 pounds, 300 pounds. We have 300 pounds. So I just, again, summarize that one minus 150 pounds plus ny, which is a opposing force just like A. So they have similar signs, which is positive, is equal to 0. So what will happen here is that we want only this ny, so we transpose all of this to the other side of the equality. So we have ny is equal to 1,300 pounds or 1,300 pounds going upward. Why going upward? Because it's a opposing force of these forces above. So these are negative forces, while these two are positive because they're opposing force. So as we continue this problem, we use the section method to solve the particular forces, which are this one, DF, EF, and EG. So I make a simple diagram of that, which we only need to find this force DF, DE, and EF, this one. Okay, so using the sector method, we can find those, and my partner will complete the solution for finding those forces we have to find.
By passing a section at members DF, EF, and EG using the previous given free body diagram, we could then apply force DF at F. With this, moment at E, which is equal to 0, is present, and having the values 200 pounds to 18 feet plus 400 pounds to 12 feet plus 400 pounds to 6 feet minus 1,500 pounds to 18 feet minus the opposite over the adjacent, which is 18, and the value of this multiplied to the force DF, and then multiplied to the length, which is 4.5 feet, then equal to 0. Simplifying this, this moment, we will have 3,600 plus 4,800 plus 2,400 minus 27,000 minus 18 to the square root of 17 over 17 FDF equal to 0. Simplifying this further, we will have a value this. Then if we multiply 17 here, we could negate this, having these values only, leaving FDF, then multiplying 17 to 16,200 will have 275,400. Then we have 18 negative square root of negative 18 square root of 17 here, divided by negative 18 square root of 17 on both sides will negate this, leaving force DF present here. Then simplifying this will gain a force DF is equal to negative 3,710.80 pounds, or force DF is equal to 3,710.80 pounds compression. Now, having moment at A equal to 0, will have the values force at EF, member EF, to 18 feet minus 400 pounds to 6 feet minus 400 pounds to 12 feet, of course, equal to 0. Simplifying this further, we'll have the values 18 at force at EF minus 2,400 minus 4,800 will have negative 7,200, and transposing it on the other side will have a positive 7,200 divided by 18 coming from the values here at force EF would negate 18 here on the other side, and divided by 7,200 will have force EF at 400 pounds, with making it positive, therefore it's a tension. Then furthermore, we'll have applying moment at joint F equivalent to 0. We'll have these values here, which is force at EG, member EG, to 4.5 feet minus 1,500 pounds to 18 feet plus 200 pounds to 18 feet plus 400 pounds to 12 feet plus 400 pounds to 6 feet equal to 0. Simplifying this further, we'll have the values 4.5 force at EG minus 27,000 here, then here we have 3,600, then 4,800, then here we have 2,400, giving us the values negative 16,200 once on the other side. Then transpose, we have a positive value of 16,200 divided by the 4.5 feet, the 4.5 here. Then we could negate this, then divide here, then we have the value 3,600 pounds. It's a positive, therefore it's a tension.